Hello friends, welcome to CS Digest, and in this video we will be studying about how to minimize a DFA. Okay, so minimization of DFA is nothing but the reducing the number of states without affecting the function of machine. Okay, for example we have let's take 5 different states. Okay, suppose we are given a string and it takes 5 different strings to give an output. Let's take random input symbols. Okay, so is it possible to design that machine using less number of states? Okay, so for example this DFA can be designed in 4 states or 3 states, which will make our computations very much easier. Okay, so this is what minimization of DFA is. Now let's see how can we minimize the DFA. Let's take a question, and using that question we will see how to minimize the DFA and what are the rules involved in that. Okay, so let's take a present state and next state. Let us take two input symbols 0 and 1. Okay, and let's take Q0, let be initial state, and let's take Q6, 7 and 8. Okay, so these are 9 states we are taking, and let Q2 be the final state. Okay, and let Q0 on 0 go remaining on Q0, and on 1 also it is on 1 it is going to Q1. Let me quickly write it down. Okay, so this is our question, and let's see different steps involved to minimize this DFA. Okay, so this is nothing, we are writing just the present state here, and on what input symbols it is going on which state, that's all. Okay, so here initially there are 9 states. Let's see how many states can we bring down. Okay, so step 1 will be identify unreachable states. Okay, what are unreachable states? Unreachable states is nothing, it is just starting from initial state we can't go to other state, so that state would be known as unreachable state. I tell you, so see here Q0 is our initial state, so we can go to Q1 on 1. Okay, so Q1 is a reachable state. Okay, so this is unreachable and this is unreachable. Okay, so here let's see for Q2, we can go to Q2 also from Q1, because see from Q0 we can go to Q1, from Q1 we can go to Q2, so Q2 is reachable from Q0, right? So Q2 is also reachable state. Now let's see for Q3. Q3 can we go? Here we can't see Q3 we can see here, but let's see, is Q8 reachable state? No, because we can reach at Q8 using Q3 and we can go to Q3 using Q8, but we can't go to Q3 and Q8 using Q0. Okay, there is no way you can figure this out from this individually going through everyone. So Q3 and Q8 are are unreachable states. Q4 we can go, yes, we can go from Q1, Q5, Q5, yes, we can go to from Q2, Q4 also reachable, Q5 also reachable, because Q2 is reachable, so Q5 is also reachable. Okay, now Q6, Q6 also we can reach through Q5, so Q6 also reachable. Q7, Q7 we can go through Q4, so Q7 is also reachable. And Q0 is obviously reachable because it is our initial state. So these all are reachable states, and these two are our unreachable states. Let's write this down as S1. Okay, so it will be Q0, Q1, Q2, Q3s are unreachable, so Q4, Q5, Q6, Q7, and Q8 is are unreachable. So here we delete Q3 and Q8 states. Now let's go to next step. Next step is separate final and non-final states. So which is our final state here? See, Q2 is our final state and everyone else is our non-final states. Remember, there can be multiple final states also, but here it's only one final state, that is Q2. So let's write it down and name it as S2. So it is Q2 is our final, and write every other state in another set. Q0, Q1, Q4, Q5, Q6 and Q7. Okay. Now the next step is we have to separate those states which directly go to the final state. Okay, what do you mean by that? See here. Q1 is directly going to Q2, that is the final state. Q2 is the final state only.